Today's AMATS topic is on chapter 2.6 on modulus function. But before we do that, I want to bring you back to your Sec 1 physics, the very first chapter that you have learned on physical quantities. We learned that physical quantities, they describe physical properties of objects by measurements, and it consists of magnitude, which is the amount or the size, and then we have the units. So why am I talking about this? We also learned that in physics, we've got displacement and distance. And you know the difference between displacement and distance. So displacement can be positive or negative depending on the reference point. Okay, so for example, if this is the origin, and if I were to assign the direction to the right as positive, which is usually the case, for example in a number line, we say that the displacement of A from 0 in this case, for example if this is 2 meters, so we say that the displacement of A from the origin is 2 meters. Now let's say we have this over here, B. Over here we've got 2 meters as well. We will therefore say that the displacement of B from the origin is negative 2 meters. However, in both cases, we can say that the distance of B from O is 2 meters. We also say that the distance of A from O is also 2 meters. Okay, so here we have different words: displacement of A from O, distance of A from O, both of which are positive 2 meters, and we've got displacement of B from O is negative 2, but the distance of B from O is positive 2 meters. Okay, so this is just a recap on your physics that you learned in lower sec. What is this got to do with mathematics? You see, in life, sometimes we are concerned about magnitudes. We may not be so concerned about the vector quantity. Okay, so in modulus functions, our aim is to rewrite these negative values to become positive values, because sometimes you're only interested in the magnitude. Okay, so what do I mean by this? Let us take x to be the displacement again. But this time, we are only interested in the magnitude. So you would agree with me that x, which is the displacement, can have negative values. In this case, an example will be B. It can take a value of 0, which is at the origin, and it can take positive values, one of which the example will be at point A. But suppose we only want the magnitude. This is what we will write. We've got two vertical strokes over here. They are read as the modulus of x. So if we see this, we call it the modulus of x, meaning I only want the positive value, which will be the magnitude of x. Okay, so in this case, if I have x sub x equals to negative 2, which was the case in B, we are going to get the absolute value of -2 is 2. Okay, so this modulus sign changes a negative value into a positive value. What remains is only the magnitude or the size. So if you want an example, in physics, we are actually converting displacement to distance. Okay, so what if we were to sub x equals to 0? Then we will have modulus 0 equals to 0. And let's have a third example, sub x equals to 2. So modulus of 2, which is the magnitude of 2, is simply 2. We see that over here, in these two cases, there is no effect. The modulus sign does not affect the result in any way. But in this case, what the modulus sign does is to change a -2 into 2. So we actually can have a summary. Okay. And our summary is that modulus x is going to be equals to x if x is positive. Okay, this falls into the case over here. There is no change. Now this can also be equals to 0 if x is equals to 0. Okay, which was the case over here. And finally, it will be equals to -x if x is less than 0, which falls under this case. Okay, so let's just link these back. I want to compare this last case. See if they are really equivalent. Okay, so let's say, for example, let x be equals to -2. Okay, let's choose something different. Let's say let x be equals to -10. Okay, I'll substitute this into my modulus x, which gives me modulus of -10. The modulus of -10 is going to be equals to, see, this is what I've written, modulus of -10 is supposed to be equals to -x. Okay, let's write down the negative, and the value of x, earlier on we said that it is -10. So this results in a positive 10. Okay, now after you've done it many times, it becomes really straightforward. All we need to do is, for example, modulus of -8 is simply 8. Modulus of -1 is simply 1. More examples, modulus of -100 is 100. Modulus of -98, if you want the full working, it will be negative of -98, which is simply 98. Okay, this is for the third case. Now recall that I said when x is equals to 0 or when x is positive, referring to these two cases, the modulus symbol actually doesn't do anything. It is only when x is negative that the sign changes to become positive. So we can actually rewrite all this. We can summarize it further. Okay, and this will be found on your textbook, page 72. What we have is that if x, modulus x is equals to k, where k is more than or equal to 0, and we see that this is actually a combination of these two. Okay, if modulus x is equal to k, where k is more than or equal to 0, then x will be equals to k, or x will be equals to negative k. Now this case is found over here. So let us try a few examples to see how this works. Let's take a look at work example 19, question A. We want to solve the following equations. Okay, we've got modulus 2x minus 3 equals to 11. There will be two cases. The first case is if 2x minus 3 itself is positive or greater than 0. The other case is that 2x minus 3 is actually a negative value. Alright, so let's talk about the first case, where we have 2x minus 3 is equal to 11. Now when 2x minus 3 is a positive value, we say that the modulus symbol, the modulus sign doesn't do anything, so we can simply remove it. There was no effect. So from here we can solve very easily. 2x equals to 11 plus 3, which is 14. So x must be equals to 7. We'll do a check later on when we substitute this value back into the original equation. Now this is one possibility. The other possibility is that 2x minus 3 could have been equals to negative 11. Now let us think about what this actually means. 2x minus 3 is found inside the modulus. Suppose 2x minus 3 value is negative 11. If it is negative 11 and you introduce the modulus symbol, wouldn't that result in a positive value of 11? So this is the second case that we need to consider. And this is how we write it. There are two cases. Okay? So solving it will give us 2x equals to negative 11 plus 3, which is negative 8. And therefore x equals to negative 4. The final step will be to substitute them back into the original equation to check whether it is valid or not. So when x equals to 7, let's see what we get. 2 times of 7 minus 3 equals to modulus of 14 minus 3, which is modulus of 11, which is simply 11, equals to the right hand side. Okay, so x equals to 7 is a valid answer. Let's try when x equals to negative 4. So 2 times of negative 4 minus 3, this gives us a modulus of negative 8 minus 3, which is modulus of negative 11, which is not a surprise because that was the case that we said. 2x minus 3 could be equals to negative 11, and we see what the modulus sign does. It changes it to positive 11, which is equals to the right hand side again. So we've got two answers that are valid. X equals to negative 4 or 7. So this is the presentation that we are expecting. I'll go through one more example, part B. Now in part B, we've got x squared minus 8 equals to 4. We can again split this up into two possibilities. The first one, just remove the modulus symbol, ignore it completely, and we get x squared minus 8 equals to 4. This will be our first case. The second case will be copy down whatever is in the modulus again, but this time change the 4 to negative 4. This is the standard step for solving modulus equations. And then we continue solving them separately. Here on the left hand side we get x squared equals to 12. So x must be equals to plus minus square root of 12. which is plus minus square root of 4 times 3 plus minus 2 square root 3. On the other side, we've got x squared equals to 8 minus 4, which is 4. So x equals to plus minus 2. Here we've got 4 different answers, and we need to test all of them. Okay, so when x equals to 2 square root 3, I will have 2 square root 3, and I square it, minus 8, which gives me 12 minus 8, which is modulus 4, which is 4. So equals to right hand side. Okay, so x being 2 square root 3 is valid. When x equals to negative 2 square root 3, we've got negative 2 square root 3, and I square it, minus 8. I'll see that I get the same answer again. Right hand side, valid. Last two cases, when x equals to 2, 2 square minus 8 gives me negative 4, modulus, which is 4. Again, equals to right hand side. And the last case, when x equals to negative 2, modulus of negative 2 square minus 8 gives me modulus of negative 4, which is 4, equals to right hand side again. So this can be summarized to x equals to negative 2 square root 3, negative 2, 2, or 2 square root 3. We've got 4 answers. So at this point, you should be asking, why is it that we need to check the answers when they always seem to be valid? So I'll be going through a question from exercise 2F, question 4C. So from question 4C, we've got 2x squared minus 5 equals to 3x. Again, the approach is the same. We copy down exactly the same question, but we remove the modular sign. 2x squared minus 5 equals to 3x. And in our second case, we have 2x squared minus 5 equals to negative 3x. So note that in the second case, all I did was to introduce this negative sign. Okay, so back to the first part, we've got 2x squared minus 3x minus 5 equals to 0. We can factorize this to give us 2x. Over here, we've got x equals to 0. So working it out, 2x and x is 5 and 1. 2x squared with a 5, 2x, 5x. I want a negative 3. So the negative sign goes here, negative 3x. So 2x minus 5 and x plus 1 equals to 0. So working this out, this gives me x equals to 5 over 2 or negative 1. In the second case, we have 2x squared plus 3x minus 5 equals to 0. Note that these two equations are different. They look very similar, but they are different. Okay, and solving this, 2x and x, again 5 and 1, 2x squared with a 5, 2x, 5x, I want a 3x. So the negative sign goes here. And we have 2x plus 5, x minus 1 equals to 0, leaving me with x equals to negative 5 over 2 or 1. So looking at these 4 answers, some of them will be valid. We need to check whether all of them are valid. So when x equals to 5 over 2, our left hand side gives us 2 times of 5 over 2 square minus 5, which is modulus 2 times of 25 over 4 minus 5, (12.5 minus 5, which is modulus of 7.5, which is simply 7.5. And on the right hand side, when you substitute 5 over 2, we get 3 times of 5 over 2, which is again 15 over 2, 7.5. So equals to a left hand side. Okay, so we see that x equals to 5 over 2 is valid. Now let us try x equals to -1. When x equals to -1, the left hand side gives us 2 times of -1 squared minus 5 equals to 2 minus 5, which is modulus of -3, which simply is 3. Let's check the right hand side. The right hand side is supposed to be 3x. So 3 times of -1, which is -3. This is not equals to the left hand side. So x equals to -1 is rejected. Now we finally see a case where a value of x, a solution for x, is rejected. Okay, do the same for these two other values of x. You will see that one of them has to be rejected as well. Then the question will be, do we really need to show the working for all these checking? At the start, I encourage you to write down all the working for the checking. But with experience, with enough practice, you'll start to realize that sometimes we can reject answers just by looking at it. So in this example, let's consider x equals to -5 over 2. Let us try and put it inside the right hand side. When x is equal to -5 over 2, my right hand side will be equals to 3 times of -5 over 2, which is a negative answer. I don't even bother to work it out. Then you have to ask yourself, if the left hand side has a modulus, can the answer be negative? So you should realize that it cannot be negative. So we know that this has to be rejected. What about this one over here? You will need to verify it. So this is the end of the lesson. Please use the remaining time to do practice now 19, question A, B, and C. Your homework questions are from exercise 2F, question 2, 3, and 4B. This is due the next day. Which is 26